I'm John McQuay with 8541 Tactical, and this is Mail Call Mondays, the show that answers your questions about precision rifles, optics, and equipment. Well, I've got the whiteboard out here. Screw your thinking caps on, because today we're going to talk about high-angle shooting. We got a question after last week's video about up angles and down angles, but I figure I'd back up and cover the entire process of high-angle shooting so we're all on the same sheet of music. Now, high-angle shooting is a little bit different than flat-lying shooting because you're going to have to make a computational change to your dope in order to hit your target. Shooting at an angle is going to be a little bit different because gravity pulls on your bullet over a flat line distance. So the distance that you would see across a map is the distance that gravity is going to pull on the bullet. Gravity doesn't care if you're shooting up or shooting down. It's still going to pull the same amount on your bullet. So your bullet is going to have the same amount of drop over that flat line distance. So how do we get the difference in our line of sight distance and our flat line distance? Well, if you look at my little wonderful drawing here, and no comments on my artistic skills, we've got our little shooter sitting down here, and up here on the top of this really crazy psychedelic looking mountain, we have a bighorn sheep. And we're not going to get into any ethical dilemmas on long-range hunting right now. This is just for instructional purposes. So let's consider that we do our range estimation techniques, and either we're range estimating with a scope or we're range estimating with a laser rangefinder, and we determined that our little bighorn is 1,000 yards away. Well, if we go ahead and plug 1,000 yards into our scope, based on our regular dope calculations, our drop sheet, or what our ballistic calculator tells us, etc., and we fire, our bullet is going to impact high. And at 1,000 yards and at an incredibly steep angle like this, it's more than likely going to miss the entire target. So how do we fix this? How do we figure out what the correct dope is that we need to put on our scope? Well, the first thing we need to know in the process is this angle here. The angle that we're shooting up or the angle that we're shooting down, because it doesn't make a difference if we're shooting up or shooting down. The process is exactly the same. We've got a couple of methods. There are a couple of different devices, angle cosine indicators that you can put on your scope that will tell you what your line of sight is relative to gravity. Now, they're cool. They're always on your scope, but you may smash one against a rock and it doesn't work anymore. They are relatively expensive, and they're stuff that we didn't have back in the day, so we learned other ways to take care of it. One of the cheapest, easiest, and effective ways to do it is with this little guy that I've got right here. This is a military Map Protractor, and we tie a little string coming off the bottom of it. Now, the Map Protractor has degrees and milliradians marked out all around the outside of its surface. The reason that we originally tied the strings on was when we're shooting azimuths on the map, it's easy just to pull the string out and measure an azimuth. Well, the added advantage of this is you've got this string tied on here, which is just a piece of 550 cord guts. Now we can take a weight, a rock, a washer, whatever we want, and tie it on the end of this. You can even tie a dog tag on it and it'll work. And now that'll act as a pendulum and hang straight down. Now you can have your spotter take your protractor and lay it across your barrel and get a good angle that your barrel's pointing up or pointing down, and read that out. And you can use that to factor in to your formula. Alternately, there are some laser rangefinders out on the market now, like the Bushnell Elite 1600 ARC, that have angle finding built into them, and they'll automatically compensate your distance based upon the up or down angle that you're looking at when you laser the target. We'll get more into these a little bit later. Alternately, if you have an iPhone, iPhones have accelerometers built into them. Some of the other smartphones do as well, and you can get angle apps to where it will tell you the up or down angle of the iPhone. So you can just basically sit your iPhone across your barrel, or what I prefer to do is sight down the edge of the iPhone at the target and lock in that angle. So those are some options. Now, once you've got your angle up or angle down, what do we do with it? The cheapest and easiest method that we used quite some time ago is to make out an angle cosine chart. Now, what the angle cosine chart is it just lists out your angles, and then next to the angle it has what the cosine should be. Now, you really only need 0 to 90 degrees. You don't even need 90 degrees because 90 degrees is going to be 0. So 0 to 90 degrees, and it will list out a number from 1 to 0. If you were shooting at 0 degrees, then the cosine is going to be 1. If you're shooting at 90 degrees, the cosine is going to be 0. Now, the cosine, if you want to do an angle cosine chart yourself, you need to get a scientific calculator, or computers will do it. Excel will print sheets out. Even the calculator on the iPhone, when you turn it sideways, will be a scientific calculator, and you can punch it in. If you're using the calculator on your iPhone, then what you'll do is you'll punch in your angle. Like, say we get a 45-degree angle, punch in 45, hit the cosine button, and it'll give you a decimal that reads out. Now, multiply that decimal by your line of sight range to the target, and that will give you your true range or your flat line distance to the target. Then you'll simply use that to calculate your dope, your flat line distance. Now, same thing with your angle cosine chart. You'll just go down, you'll find the appropriate number that corresponds to your angle and multiply that by your line of sight distance, and it'll read it out to you right away. Now, if you're using ballistic or bullet flight or one of the other ballistic calculators on the iPhone and some of the other smartphones, they may already have an angle calculator built in, so you'll just simply punch in what your angle is. Or if you're using the iPhone, you can aim the iPhone, lock that angle in, and it will adjust what your dope is based on that angle, so you don't have to do extra calculations. If you're using something like the Bushnell Elite 1600 ARC, then all you do is laser the target, and if you have the ARC enabled, it will tell you the corrected distance to the target. If you go to the trouble of putting the ballistic profiles in here, it will give you an approximate ballistic solution as well. So it's kind of neat, some of the added features that they have on it. It may not be appropriate for long-range precision target shooting, but they're originally designed for hunting and to be able to give you a close enough guess to hit your animal. So those are some options. It really, when you start talking about the formulas for angle shooting, it really seems more complex than it is. You don't need to know how to actually find a cosine other than punching it into a calculator. You don't need to know all the formulas involved or the Pythagorean theorem or any of the extra stuff that goes into it. If you want to know that, I'll leave a link down in the description section where you can go and see all the formulas and all the internal math workings to be able to figure it out. I prefer to just punch it into a calculator. I'm kind of a knuckle dragger that way. I just need to know enough to be able to get the bullet on the target. And we've been using the angle cosine charts for quite some time, ever since I went through a high angle shooting class for the Marine Corps out in Hawthorne, Nevada. And it works. It works very well. We've used it out past 1,000 yards. In fact, I think our longest target out there was 2,400 yards. If you've ever been out there, it's the old gun turret way out in the bowl. So it works. We'll leave a link to a printable angle cosine chart in the description, so you don't have to go through the math. You can just print it out. And just remember that whatever your angle is, take the cosine, multiply that by your straight line range, and use that to find your dope, and you'll be good to go. If you guys have any questions, and I'm sure you will, please go ahead and leave them in the comment section below or send them to us on Facebook or Twitter. If you've liked the video, make sure you click that thumbs up button. We like to see those thumbs up, those likes. If you dislike the video, please leave a comment and let me know why you dislike the video. I can't get better without input from you. If you're a subscriber, thank you. If you're not a subscriber, please click that subscription button. It helps us out, helps us see how many people are following our videos, and it helps us get support from manufacturers and other companies out there in the industry. Until next time, get out and shoot!